Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with not one, not two, but three modules. I'll be going over the entire trilogy of the SQL modules. The SQL modules are about finding patterns in a data table, and then submitting a correct SQL query that will give you a target result. Let's go ahead and start. This module does not require any edgework in the slightest, so as soon as we get our bomb, we can
All
get
available
started.
experts, please report to room A9.
So here are all three of the SQL modules. You have the green one, which is SQL Basic, the other one, which is Evil, and the red one, which is Cruel. These increase in difficulty in that order. So let's start with the easiest one. SQL Evil and SQL Basic introduce two different sections that are both combined for SQL Cruel. So for Basic, we are given select where with an optional conjunction of the where condition, a limit, and a skip. I will explain what these all mean, but first, let's get our goal. The goal is to submit an SQL query that will result in this. So, what the heck is an SQL? So, we have input data here, and we can find our goal, which is this, in the input data somewhere. So if I control F for 1, I should be able to find a row, but not necessarily in reading order, where one column has a 1, one column has an... I'll just put this over here. One column has an 8, and one column has 6. I should then be able to find another column where one has a 4, one has... the three same columns in the same order that has a 4, the first one has a 4, the second one has a 0, and the third one has a 5. And then I should be able to find another row where the first column has a 9, the second has a 2, and the third has a 7. Which means that I have found those three rows, and I highlighted the cells that the rows I am considering are in. So the first column, which is the 149, belongs to column delta.
Emergency cleared.
So,
All personnel, please return
let's
to
select
stations.
column delta. The second column with the 802 was Bravo, so I'm going to select Bravo second. And then the third column, which contains 657, was column Charlie. So now we've gotten the three columns. Just by looking at the select DBC, the SQL module is going to receive these three columns. I'm going to use blue as the first column, red as the second, and green as the third. So if I pressed submit right now, well, not right now, there's some other things that it applies to right now, but we're going to ignore that. If we were just focusing on the select, then the module would receive the entire delta column, followed by the entire Bravo column, followed by the entire Charlie column. However, we are only looking for three specific columns, rows even, these three rows. So we're going to have to use the where and the limit skip conditions to specify which rows we actually want. So the where operation is the main way you can filter out which rows that you're going to let the SQL module receive. With the where condition, it is a logic statement. It is only going to look at rows where the logic statement is true. You can also have an additional conjunctive statement. If it's and, then the module will only look at rows where both of the conditions are true. If you have an or conjunction, then the module will only look at rows where either of the conditions are true. So we're going to look for a way to have the module strictly look for these three rows. So an example that we can do this with are, if we look at column E, the first row, E contains 2. So let's put E equals 2 as one of our conditions. And for these two rows, E is 7 and 8. 7 and 8 are the highest two values in the entire E column, So, in order to make the module recognize both of these rows in one command, we're going to make it do OR, because we also need it to recognize where E equals 2. And we're going to E is greater than 6. Because no other row in the E column is less than 6. So, now that we've done this, the module is only going to recognize rows in which E is equal to 2, which is this row, and rows where the E value is greater than 6, which are these two rows. And because of the select in the specific order that we have, it's going to recognize the delta column, then the Bravo column, then the Charlie column. It is going to recognize the rows from top to bottom. You can never reorder the rows, but you can always reorder the columns. You can make the module ignore rows, but you can never make them... You can also make the module ignore columns by only selecting which columns you want. So if we take a look at our query result, the first row that it considers in the column order that we're considering is 1, then 8, then 6. The second row that we're considering, this one, is 4, then 0, then 5. And then the third row that we're considering has 9, then 2, then 7. So we're actually ready to press a check button, and when we do, the module is going to solve. But I did not go over the limit or the skip. I'll briefly go over that now. So the limit function has two inputs. The first one limits the number of rows that can actually display. So, as you saw, we had 3 rows in our solution. However, there's a chance that the module can only have 2 rows, or, maybe if it's feeling frisky, only 1 row. If we only want the module to look at 1 row, then we can have the limit be 1 for the first value. If we want to look at 2 rows, then we can have the limit be 2. But you're never going to need to set the limit higher than 2, because the maximum amount of rows that the module can generate is 3, as far as I'm aware. I might be wrong about this, but either way, you can make it limit to more rows, but that's all I've seen. And then the skip will tell the module to ignore certain rows. So if this second condition was instead echo is greater than 5, then now this row applies to our condition. Actually, no, that's not how this works. I'm sorry. I apologize. So, let's see. Let's say that the first condition was echo is less than 2. Now, if we put the limit to 3 rows, then the module is only going to look at the first 3 rows that fulfill the conditions. So the rows where echo is greater than 3 and the rows where echo is less than 6 will be the 5 rows I have highlighted in blue. If we told it to limit to 3 rows, then the module is going to look at the first 3 rows that apply. And with the skip condition, this is the number of rows that the module is going to ignore. So if we look here, for example, let's look at this one, for example, the limit 1, 2. So the first value means that the module is only going to take the topmost row, which is this row. But since we're skipping 2, the module is going to skip over the first 2 rows and only look at the third row that the data set consists of. So if we put to skip 1, then the module is going to skip the first row that the data set consists of. Meaning the module is only going to look at these 3 rows if the limit is set to 3. Which means it's not going to look at this row, which means if we had echo is less than 3, set the limit to 3, and skip 1, then the module would have also solved. But you can almost always not use limit. Using limit is kind of more complex, but it might be necessary in some cases. If you can avoid using limit, I would just avoid using limit. It just makes your life easier. So now we're going to move on to SQL Evil. Now, despite its having the word evil in its name, this model's actually not that bad. So the first main difference you're going to see is that the data table is different, as you may expect it to be. This is the select, my bad. So the data tables are different. The main thing you're going to notice is that the columns only have 3 unique values each. So let's go ahead and get our goal up. For SQL Evil, you are always going to get a 3x3 grid as your answer. You may notice here that you only have a select and a group by, as opposed to where and limit with SQL Basic, which limited the number of rows that the module could look at. And additionally, oh, my bad, I'm wrong. You can have it to where it can display only 2 columns, but you are never going to have it to where it's going to have any number of rows less than 3. It will always have 3 rows. Because we can't limit the number of rows that we're looking at because we don't have the limit. So now we're going to do SQL Evil. So now we have select and aggregators, as well as a group by. So what do these mean? So an aggregator is only going to take one specific value for all of the columns it is considering. Either the minimum, the maximum, the average, the sum, or the count. And I suppose this will make more sense if I explain group by first. When we use group by, the module is going to sort the rows. As you can see in this example, if we are grouping by C, which it does in this example, it is going to take all of the rows that have the topmost value of C and group them together. So we're looking for all rows that have a C value of 0, which are these 2 rows, which the module has grouped together. It omits the C column for whatever reason, but I guess you don't need the C column because all C values are equal to 0, and that's just a blanket statement. Anyway, back to this. Next, the module is going to look at the next row that it has not grouped yet, which is going to be the one with the 3 in it, and then it's going to group all of the columns, all of the rows where the C value is 3. So these two rows are grouped together. And then finally, it's going to look for the third value, which is 7, and then it's going to group all of the rows where C is equal to 7. So that's what group by does. And the aggregators will only consider the columns that... This is a bit confusing, I'm so sorry. Let's see. It's going to output columns in this table format that have a certain value. This is so hard to explain. I am going to apologize a lot, but anyway. So let's look at this for example. I think it'll be better for me to explain it if I have an example to look at. So, with count A. Count A is going to correspond to the first column of the result. What count A does is counts the number of cells that A has. A has 2 cells in the first group where C is equal to 0. So the first count of A is going to be 2. In the second group where C is equal to 3, A only has 2 values, so the second row is going to be 2. And for the third group where C is equal to 7, A has 3 cells, so the third row is going to be C. When it comes to the average function, it's going to take the sum of all of the values in the group. So where C is equal to 0, B is equal to 5 and 8. So we're going to take the sum and then divide it by the number of data points there are. And if you get a decimal, you're just going to chop that decimal right off. So we're only looking at the integer part. So 6, as it says in the result. For the second one, we're going to take 8 plus 8, as those are the b values when C is equal to 3. Divide them by the number of data points, which is 2, which gives us 8, which is the second row. And then finally, we take the 3 data points, where C is equal to 7, divided by 3, because there are 3 data points, and that's going to be the bottom row. And then there is also you can also put just the variable itself. In the first group, C is equal to 0, in all of the columns. So 0 is going to be in the first row. In the second group, C is equal to 3, so we're going to output the value of C to the second row. And in the third group, C is equal to 7, so we're going to output the value of C into the third group. Only ever use the aggregator that has just a letter if all of the values in the group are the same. If you try to, for example, this group here, if you try to put A as one of your conditions, it can't take the value of 7, 1, and 9 because they're 3 different values. So, don't do that. So now that I've gotten that explanation out of the way, let's see if we can find a pattern in the data. So my first instinct is to look at... You're going to look for a column where all 3 values are different. So that's going to be the middle column for S, because this is an indication of the column that we're going to group by. We're looking for a column in which the first row is 9, the next row that is not a 9 is a 7, and the next row that is not a 9 or 7 is a 1, which corresponds to alpha. So if we group by alpha, that means that we're going to have group 1 consisting of all of the rows where alpha is 9, then group 2 is going to be all of the rows where A is equal to the 7, and then all of the rows where A is equal to the 1. Okay. So, we can also set the middle selector to just A, because the middle row consists of, since all of the A values in each row are the same, it's going to take the value of A in each row, which corresponds to 9 for the first group, 7 for the second, and green for the third. Now we're going to find 2 data sets that will return 4, 3, and 4 for all 3 groups. We can do this by taking the minimum number of all of the columns in each group. So if we took the minimum of G, for example, in the blue group, the smallest number is 3. In the red group, the smallest number is 3. And in the green group, the smallest number is 3. So if we took the minimum of G, it is going to return a column of 3, 3, and 3. But we're looking for somehow, we're going to get a column of 4, 3, and 4. So the first thing that we can do is look for a column that contains 4 and 3, which is also the G column. Now, if the minimum value in all of the columns is 3, if the minimum value of the blue group is 4, which it's not, then we can take the minimum of G. However, it's not, so we can't use this. If the maximum of the blue group is 4, which it's not, then we can take the maximum of G, but it is not because there's a 5. Meaning that we can't use the minimum or the maximum of G, but we go ahead and set it to G, which means we can take either the average, the sum, or the count. If we took the count, it's going to count the number of cells in the G group that are in the G column that are part of the blue group, then all of the cells in the G column that are part of the red group, and the number of cells in the G column that are part of the green group. And then it's going to output that value. So the first would be 3, the second would be 2, and the second would be 2. Which, if you take a look at the third row, is actually the third column even, the value of the third column. And since all the columns are going to have the same count, because there are 3 rows in the blue group, 2 rows in the red group, and 2 rows in the green group, we can just put the count of any column as the third aggregator. So now we're trying to find a way to get a column to output 4, 3, and 4. Which I think G is going to be how we do this, so let's take a look at the other aggregators. We can take the sum, which means it's going to take all the values in the blue group for the G column, which is 12, and output that. But since that is not 4, that is not what we're going to be looking for. And then the average, which I believe is what we're going to be looking for, we're going to take all the values in the blue group, add them together, then divide by the number of data points, which gives us 4, which is the first value. Then we're going to take the values in the red group, add them together, take the number of data points, and then chop off that decimal, just take the integer part, which is 3, and then if we do it for the green group, we should get 4. Yes, we do. So the average of G will result in 434. So we have grouped by A, and we have set our aggregators, so now we're going to press check, and the module solves. Now, finally, we're going to go to SQL Cruel. Cruel doesn't introduce anything new, but as you may notice, it combines the element of basic and evil. It contains the aggregators and the group by, as well as the where condition and the limit condition from basic. You are forced to use a one where condition. You cannot use more than one. The limit functions as normal, the group by functions as normal, and the select functions as normal. So we're going to be combining the uses of all of the tools that we have been introduced. So, I don't... No, this is not the same. The cruel table is a bit longer, so we're going to have to look a bit harder to find any patterns in the data. So let's check out our goal. So the first thing to notice is that there are only 2 rows in the table, meaning that we're going to only have 2 rows at max. So I'm going to go ahead and set the limit to 2. We'll see if we're going to skip any rows later. But first, I'm going to try and see if there is a column that contains 5 in the first row, 6 in the second. But we can also skip the first row. So from evil, let's see here. If I skipped 1, and I'm grouping by the B column, the values in the B column are 2, 5, and 8. So group 1 would consist of all of the rows where B is 2. Sorry. The first group is going to consist of all the rows that have the same B value as the first row, which is 5. Then we're going to go to the next row that's not grouped yet, and the second group is going to consist of all of the rows in which the B value is equal to the same value, and then put the remaining rows in that group. And as we saw before in the evil module, the first row was equal to all of the values in the blue group, the second was all the values in the red group, and the third was all of the values in the green group. These are the rows. So if we put the skip to 1, then that means the module is going to ignore all of the values in the blue group. If we set it to 2, then it's going to ignore all the values in the blue and red group. You can set this to up to 9, but I don't know why you would ever do that. We're going to set this to none for now, and you can also limit up to 9, or limit to all. So, like I said, we have 2 rows, so we're going to limit to 2. There's no reason to go above 2 rows, since we only have 2 rows. So I'm going to look for a cell that has 5, for a column that has 5, and then 6. So the first row here is 5, meaning B is a candidate, but there is no 6 row under it, so this does not count. If we're looking at F, we have 5 in the column, however 6 comes before F, meaning that the second group would have 6 and the third group would have 5, but we need the first group to have 5 and the second to have 6, so this does not apply. And then the G column doesn't have 6 in it, so we cannot use the G column. Which means that it is very unlikely, in fact, impossible, that we're going to be grouping by the middle column. Which means we're probably going to group by the third column. And as we can see, the third has 3 and then 4. So the first group is going to consist of all the rows in which G is 3, then the second group is going to consist of all the rows in which G is 4. Since we're limiting to 2, those are all of the rows we're going to consider, so we're not going to consider any of the rows where G is equal to 5. Meaning this is the dataset that we are given. Now, because we're sorting by G, grouping by G even, we can set the third aggregator to G. And you can also you can use multiple columns for multiple aggregators, which you can also do in evil. Won't show you now because it's solved, but you cannot have multiple columns selected in basic. Anyway, we're going to look for a condition where of all the rows we're looking at, we're going to get an output of 0, 0. So the first group's output is going to be 0, and the second group's output is also going to be 0. Which, if we take a look at column C, out of all the values in the blue group, 0 is the smallest, and of all the values in the red group, 0 is smallest. Meaning that we can take the minimum of column C, and we're going to get 2 zeros as the output. And now we're looking for 5 and 6. So, let's see here. Okay, I think I see what we can do here. So I'm going to take advantage of the where condition this time. Now, I'm going to be using column F because it contains 5 and 6. And I'm going to set it to the minimum of F. Why? Well, for the blue group, you may be thinking, but the minimum is going to be 0 if you do that. And for the red group, the minimum number is also 0. So, won't that return 0, 0? Yes. Which is where the where condition comes in. We're going to filter all columns where F does not equal 0. So, the filter in the where condition will exclude any rows where the F value is equal to 0. Which is all of these rows. So now, if we look at the blue group, the minimum value is now 5, and if we take a look at the red group, the minimum value is now 6. So now, this should be correct. Taking the minimum value in all of the... Okay, thank God I checked this, because this is actually going to make the C value incorrect. So we need to find a different way to get a 0, 0 column, because we have excluded all of the rows in the C column where 0 is a possibility, which means the minimum of the blue group is now 7, and the minimum of the red group is now 3. There's no other columns given these... There's no other column in which, given these rows, can give us 0 for both conditions. Let me double check, but I'm pretty sure that is no. Meaning that this can't actually be how we get the 5, 6 row, because we are then no longer able to get the 0, 0 column. I said 5, 6 row, I meant 5, 6 column. So we're going to find a different way to get the 0, 0 column. So group 1 is still going to consist of all rows that have 3 in G, and then the second group is going to consist of all rows that have 4 in G, and then we're going to exclude all of the values of the rows where G is 5 because of our limit. So let's see what we can do here. So G is the only one that can... Let's see. Can I sum any columns blue values and get 5? Let's see. That's over 5, this is going to be over 5, over 5, over 5, over 5, over 5, over 5. So no, we're not going to take the sum of any column to get 5. We tried the minimum, where we excluded F is equal to 0, but that ruined our C column. What about the average? Let's see if we can do that. The average would be 3 here. The average would be 4. Right, because those are the same values, duh. What about this? 971 divided by 3 is going to give us a 5, maybe. And then 7917 divided by 4 gives us 6. Okay, so we have actually found some way we can do this. If we take the average of all the values in the A column for both groups. 9 plus 7 plus 1 divided by all 3 data points gives us 5, because we're chopping up that decimal. And the average of all of the values in the red group is 6. So this will give us the 5, 6 row we're looking for, and the minimum of the C is 0 for both groups. So now we actually can submit what we have as our aggregators, but we still have to deal with the where condition. And you could just set this to something that applies for all rows. It shouldn't be that hard to do this, but you have to have a where condition. So I can set it to A does not equal 0, because there are no rows where A is equal to 0. So this won't filter out any rows. So if we press the check button now, The module solves, and we have solved the trilogy of SQL modules. This is a very complicated trio of modules, so please, if you have any questions, put them in the comment section. And I will try to answer them as well as I can. Please feel free to ask questions, as just doing one example for each it shows you how to do it, but there might be some additional problems that pop up if you do this module a lot. But just ask me and I should be able to answer them for you. Thank you for watching the tutorial, and have a nice day.